Hello everyone, and thanks for joining us for the next instalment of our Improving Healthcare with Simulation workshops. We've had a great response to the workshop so far, and delighted to be presenting the next workshop along with Brittany Hagedorn. Just a few housekeeping slides. If you could skip to the next slide please, Brittany. Just a few housekeeping things just to get started, get these out of the way. Everyone is muted currently, and will stay that way throughout the presentation. But if you do have any questions, then please do use the chat panel, which is down on your right hand side. Just type straight into the chat panel, and I'll be sure to get back to you and get those questions over to Brittany. We'll also be running a few interactive polls throughout the talk today, just to keep everyone involved, and Brittany's going to be asking a few questions and getting people's views on certain topics throughout. So look out for those, and please do join in. And finally, we've got a recording will be available on simulate.com, and we will email a recording around to everyone, and to make sure that we have that, and that should be coming out within the next few days. So if you could skip on to the next slide please, Brittany. Yeah, it gives me a great pleasure to introduce this workshop, and to introduce Brittany as Simulate's new healthcare lead for North America. Simulate, really excited to have Brittany on board. She shares the mission and shares the views of us, which is to promote the use of process simulation and related tools within healthcare, and really is a great advocate for that. I mean, the role will include a lot of things, but mainly what you can see is supporting your users, publicising the great work that's already being done, and putting in a lot of effort, in things like the user group, and like we're doing now with to grow the simulation community. So it's not just users of Simulate, but it's those interested in process simulation and how it can be improved in healthcare. And as authentic as that, we have ambulances in the background. But also Brittany will be involved pioneering new applications within healthcare and developing tools and training programs for that. So it really is kind of full service with Brittany, and we are delighted to have Brittany involved. And Brittany's got a great history and a great work that she's going to talk through today, so it gives me great pleasure to pass over to Brittany. Over to you.
Thanks, Stephen. Good morning, everybody. I guess I'm really excited to have everybody with me today to tell you a little bit about my background, but more importantly to tell you about a really interesting project that we're going to talk about today. So I can't wait to get started. So with that, I will give you a little bit of background about myself, just so you know kind of the perspective that I'm coming from and where this kind of project came from. My experience within healthcare has really been in project-oriented roles. I started out as an industrial engineer and moved into the world of Lean and Six Sigma, of process improvement. And that was a really exciting role for me because it really gave me an opportunity to see a lot of different aspects of the healthcare delivery system, working in hospitals, working with medical groups, working with the folks who are really on the floor providing care day in and day out. And I got to do a lot of the really traditional operational improvement work, including nursing workflows, throughputs, reducing double checks and duplicative work. But ultimately, what I found is that led me into the clinical quality and patient safety world. So going beyond streamlining workflows to how do we create workflows, how do we create workspaces that support patient safety, support staff safety, and really will enable higher quality care and better outcomes for patients. Ultimately, that led me into more of a management consulting role, and that was a really interesting perspective for me because it gave me a chance to see kind of both sides of the challenges in healthcare and how strategy can drive operations. Operations needs to support the bigger strategy of the management and the executives in the organization, and if what I saw was often some missing links there that that there were pieces that weren't necessarily getting communicated or connecting. And so, you know, what I really started to think about was, how do we create better tools? How do we do better work and enable decision makers to make more informed decisions about their operations and their strategy and how those two pieces link together. And so that's really what led me into coming back to simulation, which I had seen and had worked with originally in my very operational oriented role. So that's kind of my perspective on all of this, and you'll hear some of those themes throughout the presentation. So I look forward to hearing your perspectives on it as well. Okay, so really quickly, we're going to talk through what was the objective of the project, what were we trying to do, what was the background. I'll show you the results on the actual data that we got out of it, and then talk through the recommendations. I think this is the most interesting part of it. The technical piece and the results is really fun, and I think we did a great project with it. But really, ultimately, if you run the simulation, you have to be able to make effective decisions with that information. And so that's where the recommendations come in, and we'll talk through some of the challenges that we faced, and that's where you get to be participatory and vote on what you think is some of the best options. And then we'll open it up for discussion and talk about next steps and how you might get involved with simulation if you're interested, or expand your use, or get involved in the user groups if you're already a user. So let's get started. Okay, so the project that I want to walk you through was one of my very first simulation projects, and so this is it was fairly straightforward, fairly simple in terms of the actual technical piece of it, but it had some great results. So the situation, a local hospital, part of the system that I was working for, was constructing a new bed tower, and as part of that bed tower, they were going to redo their operating rooms, and in particular interest for us, their pre- and post-surgical suite. So this is the space where if I'm coming in to have surgery, I come in, I spend maybe an hour getting prepped, I go to surgery, and then I come back to recover. And so the question that was originally asked was, can we have an Excel analysis that will tell us how many patients, specifically observation patients, we're going to have to move from the suite, the pre-post suite, into the inpatient units on a daily basis. Because of certain clinical needs and workflows, that was something that was already happening. But they wanted to know, given their new volumes and their new processes, how is that going to affect those numbers? And after discussing this with the executive team, we said, really, we think what you need is something a little bit more dynamic. An Excel analysis is great, and it will give you a number, but it's not really going to show you what the variability is around that, where some of your challenges might be, and help you get a little bit deeper understanding of the downstream effects of any decisions that you're going to make. And so that's ultimately what we wrote the project charter for. So this is a quick overview of the process. So it's not, as I said, all that complicated really of a process. You had 3 entry points. You had your inpatients, you had outpatients, and you had add-on surgeries, kind of those oddball cases that need to get done day of, and you slide them in wherever you can. You had your prep, right? So that's making sure that you've gotten your antibiotics and that you've gotten the drugs you need and that your screening has been done and that nothing's changed, and doing all that kind of prep paperwork and things. You go to surgery, and then after surgery you have to come out, recover from your anesthesia, and then you go to one of 3 locations. You either go home, you go to back to your unit. If you're an inpatient, you're going to go back to that inpatient unit for post-recovery. Or you could be an observation patient, in which case you're going to stick around for a while. Maybe you had open heart surgery. You know, you may be able to go back to your unit eventually, or you may be able to go home eventually. But we want to keep you in the surgical unit for 6 to 8 hours, just to make sure that everything's okay, right, and that things went well and you're not going to have any challenges as you're on your way home, right? We don't want that to happen. So the process itself, right, is fairly simple. It's a 3-step process, right? Prep, surgery, recovery. The challenge with this particular process is that not every patient is going to be the same, depending on where you're coming from and depending on what type of specialty you have or that you're coming in for. You're going to have very different time durations in terms of how long it takes surgery, how long recovery is going to take, how you're going to get routed out, as well as what OR you're going to be in and managing the block schedule as well. So there was some complexity in the background, but in terms of the process it was fairly straightforward. And that allowed us to have a pretty simple model as far as the layout goes. So you see you have 2 entry points on the left. The one on top is your add-ons. So they're going to come in throughout the day and they're just going to wait until there's an opening. Maybe somebody canceled, maybe there was a schedule that didn't get filled, and they're going to slide in there. All of your other patients are coming in that bottom arrival point, and those patients are everybody else, everybody who was on the schedule for the day. They're all going to come in there, and then they're eventually going to filter through into the process. You see there's check-in queue, so people are going to check in if they're outpatients, and then they're going to go up and wait for surgery prep. They're going to go through that process. They're going to go through surgery. So you just have those 2 process boxes there. And then everything else down to the right is the post-surgical routing. And so what we were able to do with this model is keep it fairly simple in all of the things that aren't explicitly what we're interested in, right? We don't need to model the surgeons. We don't need to model the nursing staff. We don't need to model any of the pre-surgery prep processes or what's going on there. We only modeled the routing out because that was really what we were interested in, because we wanted to understand the observation patients, right? And the only difference for them really is once they get out of surgery, where do they go after that? And so that's what you see there in that routing box on the right. Up at the top, you also have your resources. So we really have 2 resources. One is your pre-post surgical beds, so the beds in which you would come in, get prepped, and then go back and recover in. And then the other resource is your OR room, because if somebody's in your OR room ahead of you and they run late for whatever reason, you're not going to be able to start surgery on time. And so the OR rooms are broken down into 5 categories simply because we had different specialties that we wanted to model. But that's essentially functioning as one resource. So the model itself is pretty simple. A side note, for those of you who are familiar with Simulate, if you look at the entry points, you'll see that those are actually queues and not the traditional arrow logos that you would normally put in for an entry point. And that enabled us to do some more complicated things with the block schedule. You wouldn't need to do that, but if anybody's interested in finding out more, I'd be happy to talk through it afterwards. It was something that we did that I thought was pretty creative and fun to do. Okay, so the other thing I think that was really powerful with this project is that we built Simulate allows you to export data to Excel at the end of every run or at certain points in time. And so what we were able to do is export data that essentially looks like real-time patient-level data. And so, if I go to my electronic health record today and I say I want to report on every patient who came through the OR in the last 6 months, give me their start time, their specialty, their physician, the OR room, all of this information, their timestamps, give that all to me, and I want to do some analysis with it, right? I'm sure some of you do this on a regular basis, right? You take your data, you analyze it, you graph it, you chart it, you run your statistics, whatever it is that you're going to do, and then you have some information. What we're able to do with Simulate is essentially recreate that report that you get out of your EHR out of the simulation. And so with this information, we're able to then do any analysis that we want, like we would on real historical information. So what you see here, this is just a screenshot, an example of the data that we pulled, but you see the patient identifier, which in historical data would be your MRN or other identifier, your patient type and their specialty, their OR room, and then you have 3 fields there that are your scheduled start and stop times, your durations, and then you also have your actual durations and start and stop times for each step in the process. And so then we can compare that and we can do some fun things with that. Great. Okay, so with all of that said, that's our model, right? That's what it looked like. And so coming back to the original question, which was how many observation patients are going to be moving from the post-surgery unit onto my inpatient unit, what we found was that about 1.3 was our average number. And so if you remember, originally we'd been asked to do the Excel analysis. And so that's the number that we would have taken back to the leadership team if we had done the Excel analysis, is 1.3 patients per day, period. So if we look at this chart on the left, what we see is 1.3 patients per day is really not a useful number because you have significant variability between the days of the week. And that is due to the specialty mix and the block schedule on that particular day. So on days that we had, I think it was cardiology, we had many more observation patients. On days where you have a lot of ortho cases, maybe not so much. And so you see there's quite a bit of variability on between days, and then also within day. Those error bars there represent the variability that we saw within the model as well. So not every Friday is going to be exactly the same, but you can kind of get a feel for what those days would look like. And so I think this is really the power of the simulation, is that we look at that variability and get a little bit better picture of what's going on in the model. And so this was really great, and we took it back to leadership, and they were like, wow, this is awesome. This is exactly what we needed. But what we found was that we had some other results that were concerning. And so everything looks great, but when we looked at the model, what we noticed is that we were building up significant queues, significant waiting times for patients waiting to get into pre-surgery, right? Waiting to get into the preparation phase before surgery. We didn't really know why, and actually, the natural assumption is to say, oh well, my model must be wrong. Maybe I did something wrong. Maybe I assigned a patient wrong. And we looked and we looked and we looked, and eventually what we found was that no, this is actually what's going on, and so the question is why. And so you can see on the left there's 4 metrics. We ran this model at a couple different patient volumes just to get a feel for how that affected things, because obviously the strategy, part of the reason for building the bed tower was to grow volumes, right? And so we want to make sure that our facilities are going to be able to handle those volume growths. So the 2 metrics that I want to specifically call your attention to is the percentage of days with delayed surgeries. And so you can see that starts at 67% given current volumes. What that means is that 2 out of 3 days we're going to have some patients delayed, not being able to get into surgery on time because they're delayed, they can't get into prep. We still don't know why at this point. But 2 out of 3 days we're going to have some problem. And then I think the more important question is how many patients are going to be delayed when there is a problem. How bad is it? And you can see it starts at 6 patients per day, and it grows to 10 patients per day as we increase volumes. And then obviously the number of observation patients going to the floor, that's the other metric that we originally built the model for. So of course we want to continue to track that. And you can see that grows from 1.3 to 2.1 as our schedule grows as well, which, all of that makes sense. But I think the question that we really thought about for a long time is, why are our patients not able to get into prep? They're arriving on time, they're sitting in the waiting room, they can't get into a bed. So what's happening to those beds that they're not available? It seems very odd, right? If we built this, if we designed this space appropriately, we should have enough beds for the patients we're going to see. And so, it was a little bit concerning. So given that, what we did is we started looking into it a little bit farther, and this is operationally what we found is happening. So if you think about it from a process perspective, I have an observation patient who is coming out of surgery, and maybe they started their surgery at 7 a.m. and now it's 9 o'clock and they're coming out of surgery and they need maybe 6 hours of observation. Okay, so from 9 o'clock until 3 in the afternoon, that patient is going to sit in that recovery bed. Okay, and these pre-surgery and post-surgery recovery beds are all the same. Okay, so they're built to be flexible, so you could switch back and forth. And we know that we have 40 beds for both of those, both prep and for recovery. And so what happens is I have all of these observation patients coming out of the OR and sitting in beds for 6, 8, 10, 12 hours sometimes. And what that means is that as my day goes on, I'm filling more and more of my capacity, my bed capacity, with these observation patients. And so I'm running short, and I don't have enough beds free to be able to bring in the next patient to prep them for surgery. And so what you see going on in this chart, the blue line is the number of beds in use over the course of this particular day, and the green line is the number of OR rooms in use over the course of the day. And so what you can see is my blue line rises, right, early in the morning as I have all of my patients arriving for the 7 and 8 a.m. starts. And then at about 8:30, I run out of beds. And so I've got all of these patients coming in, and I don't have any beds left to give to the next patient coming in to be prepped. And so what you see, that flat line up on the top, that's when I'm at full capacity. And as soon as a patient leaves, I'm immediately turning that bed over and getting somebody in, right? And I'm churning as fast as I can, but you really can't change a recovery process. Really, you can't push a prep process. It takes what it takes. And so this green line, you see that kind of double bump. What's happening is that my patients aren't getting prepped in time, and so they're not getting into surgery on time. So my OR and my physician and my staff are all standing in the OR waiting for the next patient to show up. And so you see that decrease. That's because no patients are getting through, and I'm not getting my on-time starts. And then eventually, right, the capacity lets go, and patients start leaving in the early afternoon, and then I get that second bump, which is patients getting back into the OR, and I'm restarting some of those schedules. But what it means is that I end up running my schedule fairly late that day. So there's two things that could happen here, right? I can either, when I run out of beds, and I'm backing up my ORs, I can either cancel surgeries, which of course is going to have a revenue implication, or I can say, you know what, this is just the way it is, staff, surgeons, you're going to have to stay late, right? But that is also not an attractive option because my staffing costs are going to increase because now I'm paying overtime, and no surgeon likes to sit around in the OR with nothing to do, right? That's not going to help my physician satisfaction and my referrals and all of that. So this is really not an acceptable situation, right? I can't open my doors on day one and have this happen. So the question then is, what do we do? How do we fix it? So there were three solutions that we considered and that we modeled. And these three solutions in particular are really all non-structural. There was not really an option at this point because it was so late in the game and construction was already underway for us to move walls, to really change any design features. But that would have been great if we had had the opportunity to do it. So these are really all operational changes that we could think about making. So the first one that was suggested was, well, you know what? We're looking at this layout in front of us, looking at the architectural plans, and we see these 4 pre-admission testing rooms, which were right adjacent to the pre-post suite. They're actually inside the suite, right? But they're right next to those beds. And the question was, could we retrofit them put some beds in there, move the pre-admission testing out of the suite, which is not great. We'd like to keep them in the suite if we can, but it's an option. And could we repurpose those and make them into recovery spaces? This isn't a great scenario for a couple different reasons, including we'd like to have pre-admission testing in the OR suite, but also these rooms are going to be rooms as opposed to curtains, and so there's going to be some challenges with that as well in terms of nurse staffing and making sure that people are getting appropriate attention. So not ideal from a patient safety perspective. The second option is to look at the family waiting policy. So at this point in time, give you a little cultural background, a lot of the hospital's competitors were moving towards a model where as a patient and as a patient and as a family, I come in the morning, I go into my prep room, and as a patient, I leave for surgery, but the family is allowed to stay in that room during the surgery. So they could have lunch, they could watch TV, they could talk, whatever it is that they wanted to do, with the idea that it's a more comfortable environment, it gives them some privacy, and it's really built around the patient satisfaction goal. And then after surgery, that patient would return to the same room, so they're already familiar with the room, their family is there waiting for them when they get out of surgery, and that was kind of the plan and the process that they were hoping for. Part of the construction phase of the project was actually to expand the number of rooms so that they would have enough space to do this. That was the goal. The third alternative that we looked at was the policy around the observation patients, which again was where we had started this whole project. The question was, can we think about this policy and maybe make some modifications? And so the question that was on the table was, is there a point at which if we say this patient is going to be here for 4 hours for observation, okay, fine, maybe we have them stay in the suite. If the patient is going to be here for longer than 12 hours, longer than 24 hours, we ask them to move to the inpatient unit as soon as they can. And so they're transferred out and we regain that bed capacity. And so can we modify that policy? And then if we do modify the policy, at what point is the appropriate threshold, right? Is it 4 hours? Is it 10 hours? Is it 24 hours? Okay? So those are the three alternatives. So I would love to know what it is that you think would be most effective. What does your instinct tell you? What does your experience tell you? Is it to reclaim the pre-admission testing rooms? Is it to ask families to move to the waiting room? Or is it to move observation patients and change that policy? So I will give you a moment to vote. What does your intuition say? What does your experience tell you is going to be the right solution? This is purely from a technical perspective. What is the right technical solution? Give you a few more moments to make a selection. Then I think we're going to go to results. Stephen, can we see what everybody has to say?
Okay, there we can see the results up now, and it looks like overwhelming favourite there is ask families to move to the waiting room during surgery. 14% of which, well, the first option, reclaim 4 pre-admission testing rooms, 57% for the ask families to move to the waiting room, and 29% have moved observation patients to the inpatient beds after surgery. Is that what you expected there, Brittany?
That is interesting. So we got a pretty reasonable split, actually. You know, the initial response when we sat down with the project team was actually they thought if we can reclaim the 4 testing rooms, that would be the right solution. What I do think is interesting is that you have a lot of experts on the call here today, and that we have that many that much disagreement about what the right solution is, I think is really the reason that we do simulation, right? It's the reason that we test these, because you never know, and majority rules is often not the right answer.
Yeah.
All right, so given all of that information, all right, there we are. So actually the best technical solution was to move to the family waiting room, or to change the family waiting room policy. So congratulations to those of you who did select that. So in this case, majority rules actually would have gotten us the best technical solution. So that's great news. What we did find is that changing the policy had some interesting effects. It did reduce the percentage of delays, or percentage of days that had delays on them, down to 45%, which is a great improvement, down from 77. But is it necessarily down to 0, which of course is what we want? But I think the most powerful statement is that the number of patients that were being delayed when we did have problems went from 10 to 1, right? We saw a 90% reduction in the number of patients being delayed. And that is huge, right? I mean, that is exactly the kind of solution that any process improvement or manager is going to be interested in seeing. That's incredible. And the other piece to it is that actually the number of observation patients that we had to send to the floor went to 0, because we regained so much capacity in those beds by changing that policy. So this is fantastic, right? This is clearly the best solution, right? The other thing that we could have thought about to reduce the percentage of days that had delays down from that 45% is to think about the OR block schedule. Are there changes that we could make there that would further reduce any issues? And actually, given the I didn't mention it earlier, the Excel interface that we had built also enabled us to play with the block schedule, input the schedule in a very user-friendly way, and then the simulation would use that information. So it's something that we certainly could play with, and this seemed like the most intuitive answer for us. Unfortunately, life never seems to go quite as you would expect it. So due to other factors, this alternative was actually not what was implemented. So this is your second round of voting. What I would love to know is, what do you think was the barrier that prevented us from implementing that solution? Okay, was it technical complexity? Was it the decision makers not being in the room and not having the right team? Was it other programs that were perceived to be in conflict? Or was it other political divisions creating barriers? As a side note, I did think it was interesting that the majority chose the correct technical solution, but in this room right now we don't actually have any politics or any organizational challenges to deal with. So it was interesting that without those barriers we were able to be successful in that selection process.
Okay,
all right, so
yeah,
Stephen, do you want to go ahead and...
Yeah, polls are open there, so votes are still coming in, and again it looks like a pretty even split, but I think we have a clear winner, so give a few seconds to vote again, and then we'll get the results in. We'll close that one now, and what we can see, pretty much like the solution was too technically complex. Obviously we have some experts on the line, so no one chose that as a result there. On the others, we have 25%. We didn't have the right executives at the table, and 33% had conflict with other programs, and 42%, which is clear. Well, not a clear winner, but a winner is the political divisions created barriers to buy-in. And again, what's your comments on that, then, Brittany?
Well, it is interesting. I hope I didn't skew the results by talking about the political pieces as you all were voting. I do think it is reflective, though, of the challenges that we face as change agents within healthcare organizations that often it is the political issues, the decision makers, the other programs, the conflicts, the management issues that really prevent us from implementing things. So I think it's very interesting and a strong commentary that those were the three answers that were selected. All right, so I can just do this. Okay, so what ultimately happened is that the value-based purchasing program was really the barrier for us in implementation. So all of you who picked that third option, the perceived conflict with other programs, that was the right answer. I'm sure there are other factors as well. It's always more complicated than that, but this was really the challenge for us. As I had mentioned earlier, the family waiting room policy was really designed around improving patient satisfaction and kind of keeping up with the competing hospitals in the area. And this was done a couple years ago, and it was just as value-based purchasing was being implemented by CMS. And as you know, that program fiscally rewards hospitals for patient satisfaction scores, and a lot of this information was going public into the news, into the public domain for the first time, really, in getting attention. And so that really drove the decision not to change the family waiting room policy. And so the next best solution for us was the observation patient policy. So those 4 rooms, actually reclaiming those rooms didn't get us a whole lot. And so this was the next best option. But ultimately it's a trade-off. And so the question was, what is the right cutoff point? So as I mentioned, we could set the policy to say at 4 hours, 12 hours, 24 hours, 40 hours, when do we say, okay, enough is enough, we're moving you to an inpatient unit, you're no longer an observation patient. And so what we saw was that as we moved the cutoff point shorter and shorter, right, as we went to the right on the graph, and we were moving more and more patients to the units, into the inpatient units, we saw those delays drop off dramatically. Okay, so it's a pretty intuitive relationship. This graph isn't surprising, but I think what it does is it really forces you to have the conversation around what is the trade-off we're willing to make. Because ultimately the other factor we have to consider is the impact on the emergency room, actually, which seems a little counterintuitive at first. But if you think about moving at the extreme 10 patients per day into the inpatient units, into those med-surg beds, then those are 10 beds that we don't have available for other patients. And what is the downstream effect of this on our emergency room, on transfers, on our ability to staff those units cost effectively and to make sure that we have beds available when we have emergency cases that need to get into those units. This was not something that we ended up having the time and the resources to model, but was really the trade-off conversation that we had to have. So ultimately, this is the policy change that was implemented. So I want to really quickly share a few lessons learned with you. We've talked about some of these already, but from an overall project perspective, as I mentioned, sometimes we got results that we didn't expect, and sometimes you have to fix your model or your simulation, or you had something wired wrong. But eventually, most of those things that we found, we discovered were actually the simulation operating correctly, but the process in real life was not operating as it had been described to us. And so that was a very interesting discussion point, because at the beginning of the project, we had really pushed to do in-person observations and had gotten a lot of pushback on, no, that's not necessary, we'll just tell you how it works. And then ended up having to do a fair amount of rework at times because of that lack of understanding of the real-time process. The second piece that I wanted to talk about is the scope creep. Clearly, we started off with one question and we ended with a different one, which is, I think, is not necessarily a lesson learned in a, gee, we shouldn't do that again perspective, but an important thing to think about when we talk about planning and resources and expecting that, you know, sometimes there will be scope creep. We should probably plan that into our timeline because we know that we're going to find things that weren't expected. And then finally, the stakeholder buy-in. Clearly that is a key piece to the successful implementation of any project. Specifically related to the design piece, I did want to touch on these two. You know, we were working in an environment where construction decisions had already been made, but there was still maybe a little bit of wiggle room in terms of how the space was going to be used. And I think that the two big takeaways, for many of you this will be obvious, but for the team that we were working with, it was pretty surprising and unexpected, was that, you know, rules of thumb are not always effective, right? Because when we design physical spaces, a rule of thumb really means you're just as good as everybody else. And you know, as you work with organizations that are trying to be more innovative and creative and improve and do better than their competitors, well, why would you use a rule of thumb if that's what everybody else is doing, if your processes are different? So we really need to keep that in mind in the design process. And then the other piece is that obviously earlier is better. The reason we couldn't look at physical space changes is that while simulation is helpful at any stage of the process, you know, at that point, changing the architectural plans and the electrical plans and the approval plans, and we would have had to go through all of these extra hoops and a lot of rework to change any simple things. If we wanted to say we want the door on the left instead of right, that would have been a huge fiasco. And so we weren't able to look at some of the alternatives that we wanted to because of that. And so if we could have inserted the simulation discussion even just, you know, a month or two earlier into the design process, we really could have had a greater impact and done some really interesting and creative things. Okay, so that is the rundown on the project. I did want to leave you with one last quote because I really think it speaks to the value of simulation, and that is, great ideas need landing gear as well as wings. And when I think about that in this context, I think that we have a lot of great strategy in healthcare, and we do. Our management teams are really have really built great visions, and everybody wants to be innovative and creative, especially in this really tense and rapidly changing environment. Everybody wants to be ahead of the curve. But what we often forget is that we build these visions of ACOs and reform and all sorts of programs around patient satisfaction and improving quality, and that's all fantastic. But until you really test it out and you make sure that your operations can support it, you're missing the landing gear, right? And I see simulation as helping us to bridge that gap between wings and landing gear, right? How do we translate that? So that's my philosophy for the day. I hope you've enjoyed the presentation, and I look forward to hearing your questions and comments.
Well, that's excellent. Thanks, Brittany. Fascinating presentation. Thank you. I'm sure everyone will agree, and thank you for the insights. Thanks to everyone as well for getting involved in the polls. And we have had quite a few questions that come through, Brittany, so I'll try to get through them just now. I mean, the first one, certainly from a user perspective, actually a few of our users have asked this, is about the block schedules that you mentioned earlier. You know, you mentioned setting up the simulation differently, and it was a different way or a new way to approach it. A few people want to expand on that. Can you expand on that for us?
Yeah, so let me describe it to you. If anybody is in particular want to see how we really built it, and I can show you all of the details of it, I'd be happy to do that as well. Because I think describing it isn't necessarily going to give you the full picture. So what we did is we built an Excel interface that basically looked like a block schedule, right? We had down the side the times, and across the top the days of the week, and we could plug in the different specialties, right? So from 8 o'clock until 6 o'clock, we're going to have an ortho specialty block, right? And so we built that in Excel and then imported it into simulation. And so what we had there then in the background was at the start of every day, we would fill the schedule and then populate those patients into the queue. And so instead of using traditional entry points where there's a distribution and people are coming in at a certain rate, we actually scheduled every patient at the start of the day and then populated them into the queue and then made them wait in the queue until it was their time to arrive. So they were there all day kind of sitting idly waiting for their arrival time. We also added in some late arrivals, some early arrivals, so that we had a more realistic scenario, but that was basically how it was structured. The program would go through, and anybody who is familiar with any sort of basic programming language, or even not familiar with a programming language, but it's really just about building the logic, could build this or could use pieces of what we did to do it. So I don't know if that makes sense. I'm happy to clarify further if anybody wants to talk through it.
One thing just now, I mean, we have quite a good section on our blog on the website, which is a section of Friday tips, and it might be an idea, you know, if we put something together and we can get it up there, just a little brief tip or insight to it, just to show people exactly what you're talking about, because it sounds like it can come in handy for it, and people obviously wanting to know how to get the benefit from it.
Yeah, definitely, we should do that.
Okay, let's do that. Another question as well came in. Have you been able to reuse the model? Obviously, you know, putting the effort in and you know, building that model. So, have you been able to reuse it, or any plans to reuse it? Is it custom to that setup?
You know, it was built from the ground up without the intention to repurpose it. It certainly could be repurposed, and actually, the project continued on long after we finished this kind of initial phase. They went back and repurposed it for some additional analysis. It was all still really in that scope, but you could certainly go back and use it for a different OR suite or a different scenario. There are definitely things, you know, you build a model and then you're like, oh, if only I had known that this is what we were going to do, I would have built this differently. So it's definitely something to think about doing in the future.
Yeah, and that kind of leads me on to my next question, which is, I mean, in building it, or in building the simulation, is there anything you would have done differently? Obviously, getting through to, you know, these political divisions, you know, that we've talked about, creating barriers. But is there anything in creating the model or the process that you would have done differently there?
In the model itself, you know, one of the things we did, just like if you were doing an Excel analysis, right? If I'm going to work with a historical data file, I can try to do it the quick way up front, or I can do it the longer way, and maybe if I have to change something, then it's easier to change it later. And we did some things the quick way the first time, and then had to go back and rebuild them anyway, because we needed it to do more. And so I think the lesson learned there and what I did in future projects was, all right, take the time, do it right the first time, and make sure that it's flexible enough that I can change things. For example, be a little bit more tangible, we were looking at the specialties, and we didn't want to have 30 specialties, right? That was going to be more complex, and we didn't really need that level of detail. And so we combined them down to 6 or 7 groupings. So, you know, we put things like neuro and spine together, right? We put all the cardiology together. We kind of grouped it in logical and looking at the distributions, ways that made sense. And And we did that all kind of manually the first time. And then, of course, we took it to the user, and they said, oh, I would have grouped it differently, right? And so we had to go back and regroup and rerun all of that analysis and do a lot of, there was a lot of hard coding in there originally, and so we had to change all of it, and that was certainly a painful process, but a lesson well learned that I won't make that mistake again.
Indeed. Excellent. There's still a few more questions which we'll try to get back after. But time's getting on, and I think I'm going to finish up for today. But we'll get back, and Brittany, and we will get back to those questions personally. And I know Brittany wants to follow up after, I think personally with you guys also, and start to get some ideas. I think Brittany for next topics.
Yep.
Yeah. So we'll get those out. So as I say, we'll join us in September for the next workshop, and we'll get note of that out to you shortly. And as we say, Brittany will be in touch to see if anyone has any ideas of any future topics. We'll also be posting the recording, we'll emailing it out to you, but also posting on our LinkedIn, Twitter, and also on the website at simulate.com, and making that available for everyone there. And if you do have use any of these, then please do follow us and join in the conversation on those social media outlets. Okay, well, thanks again to Brittany. Fantastic presentation, and we also have the slides. So just say there's a few appended slides that Brittany puts in, so we'll email those out to you also and make those available. But as I say, thank you to Brittany. Thank you to everyone for joining today. Another very successful, very great turnout to the workshops, and we look forward to seeing you all again in September. Thanks, Ed.
Thank you.